Okay, so this is 5.3, the binomial distributions. So, but the binomial experiment is a probability experiment, of course. It has these four properties. That means first property is if the given experiment is binomial, that should be a fixed number of trials. Okay, so that means you should have a limited number of the experiments or trials. Okay, the second one is each trial can have only two outcomes. When you perform a trial, you should have only two outcomes. Okay, exactly, you should have two outcomes. Okay, these outcomes can be considered as either a success or a failure. Okay, it may be success or failure. The outcomes of each trial must be independent of one another. So we know what independent means. So the outcome of each trial, should not depend on another trial. Okay. The probability of success must be remain the same for each trial. When you perform number of trials for each trial, the probability of success should be same, fixed in another word. So if these all four conditions are satisfied, then we call the experiment as a binomial experiment. Okay. So now here in this example, look at one by one. You are given some trials and make sure that it's a binomial experiment or not. So you are given 20 students and you are selecting and recording their class rank. So that means your outcome is going to be now the class rank. Okay. So your experiment is here choosing a student, right? So you are choosing a student and you are putting into the class rank. So ask yourself, is this a binomial experiment? Remember, when you put a rank for 20 students, you will have rank from 1 to 20, right? That means the outcomes are now more than 2, right? Possibly more than 2. Therefore, this is not exactly, two outcomes. That means this experiment, does not satisfy the second conditions, right? Second condition says that if the given experiment is binomial, you should have two outcomes. But here I have more than that. Therefore, no, this is not binomial, right? So the trial has different more than two outcomes. That is why this is not binomial experiment. Second one, selecting 20 students from a university and recording their gender. Okay, now you are performing, 20 trials. You are checking one by one student whether the student is male or female, right? That means I'm looking for two outcomes for each trial, right? You will have either, outcome as female or male. Therefore, you will have two outcomes. The number of trials is fixed, so all the conditions are satisfied, right? So if you look at, the property number 4, the probability of each trial should be same. Yes, correct. So, we are looking for, the sex of the student. Therefore, it is fixed half chance of, choosing male or female. Therefore, it is fixed for all 20 trials, right? Therefore, problem number 3 satisfy all four conditions. Therefore, um, problem number 2. Therefore, yes, this is yes, it is binomial. So satisfies all the conditions. Okay. Number 3, drawing 5 cards from a deck without replacement. Remember, we have seen, in previous sections that you are drawing a card without replacement means this is going to be dependent events, right? Because for the second drawing, you will have one card less than the previous one. Therefore, the outcomes are now going to be changed, and probability of success also going to be changed. Therefore, this is not satisfied, number three property, right? Number three says that it should be independent, but this is dependent. So therefore, this is not satisfied. So this is not. No. Reason is outcomes are not independent. Okay. Number four, selecting five students from a large school and asking them if they are on the dean's list. So you are choosing five students. So that means you are going to ask one by one, right, whether they have their name on the list. So your outcome for each trial may be yes or no, right? Therefore, two outcomes for each trial and the number of trials is limit. All the answers are independent answers. Therefore, all four conditions are satisfied. Yes, this is binomial. So, satisfies all the conditions. Okay, all the conditions. Number five, recording the number of children in 50 random selected families. So you are going 50, you are going to 50 families and you are checking one by one whether how many children they have. So of course, answer is now we have more outcomes, not two exactly. Therefore, this is no because outcomes are now more than two, right? So more than two outcomes. Okay. So this is the way to identify whether the given experiment is binomial or not. Okay. So let's move to the next, the definition here. The outcomes of a binomial experiments and the corresponding probabilities of these outcomes are called the binomial distribution. Okay. So when you perform, a trial and you are checking the outcomes, so these kind of experiments and with the corresponding probabilities, you see, you are looking for the probabilities. These kind of probabilities are called the binomial distributions. Yes, you are looking for the probability distribution for binomial experiment. Therefore, this is called the binomial distribution. Okay. So binomial distribution, in another word, binomial distribution means you are looking for what? You're looking for the probability distribution. Okay. So we are using some, symbols with these binomial distributions. Let's look at these, symbols one by one. What is mean by P of S? P of S is the symbol for the probability of success. So S stands for success of your So S stand for the probability of the success, and the F stands for the failure. So the P of S means the probability of success of that possible outcome. This is the probability of failure. So little p is the numerical probability of success. Okay. So in another word, P of S is nothing but little p. So little p stand for the probability of success in another word. Similarly, little q stand for the probability of failure. Okay. So remember, if you add the probability of success plus the probability of failure, so this should be always going to be 1. In other words, little p plus little q should be always 1, right? For any trial. So if you look at the possibility of probability of success plus probability of failure should be equals to always 1. This means what? This means you could write Q in terms of P. That is, if you move P to the right, you will get Q as 1 minus P. Okay? So this is another relationship between P and Q. P plus Q is always 1 or Q is equals to 1 minus P. Okay? Keep in mind this relationship. Little n, we use little n for the number of trials. How many trials in total you are performing? That is little n. X, what is X here? X stands for the number of successes among n trials. So number of successes among among n trials. Okay, so you are performing in total n trials. Among n trials, you are asking yourself, right? How many trials you ended up with the successes, which is x. X is simply the numbers, positive integers. So therefore, your x supposed to be between 0 to n. N is the total number of trials, so your x cannot exceed, right? So your x may be 0. That means you did not succeed in any trial. So that's the thing. So x is all whole numbers, integers from 0 to all the way n. Okay. So be familiar with these all notations, right? If these are the notations we are given, that means the binomial probability P of x means what? The probability of number of successes you are looking, which is given by n factorial over n minus x factorial times x factorial, okay, times P of x, P of p to the power x times q to the power n minus x. We are familiar with this guy, n factorial over n minus x factorial and x factorial. What is this? If you look at your combinations, formula we learned earlier. So recall the formula we had under permutations and combinations topic. If you choose R objects from n given objects, that means NCR is given by what? Go and check your notes. That is n factorial over n minus R factorial times R factorial, right? So you have this formula in your note for the the combinations. So you have this similar expression now, but instead of R, you have now X, right? That means if you simply replace R by X here, you will get this guy as simply what? N choose X. Okay, N choose X. So that means what? That means I could rewrite this formula if you want. The probability of a number of successes is simply given by what? Simply this is my N choose X, right? So this is simply N choose X, okay, times p to the power x, then times q to the power n minus x. So this is the formula we are going to use for the binomial experiment, with the probability of success is given by n choose x times the probability of success for one trial, and n is the number of total trials you are performing, right? Q is the probability of failure. So we will do one example, then you will understand how to apply this formula for the real life problem. So look at this example two. The coin is tossed 3 times. Find the probability of getting exactly 2 heads. So you are performing here in total 3 trials. Therefore, little n is 3. Okay, before going to start this problem, ask yourself whether this is binomial experiment. Yes, number of trials is now 3, limited number, fixed number. And whenever you toss a coin, outcome will be 2 outcomes always. You will have either heads or tails. Therefore, 2 outcomes. Whenever you toss, each tossing, each trial is now independent, because the outcome of your first trial does not depend on the second one, right? Vice versa. So therefore, all 3 trials are independent trials. So this satisfies all the what the 4 properties we have. Okay. Therefore, yes, this is binomial experiment. Yes, this is binomial. So they make sure that it is binomial before going to apply this one. Okay. What is your question? Now question is, find the probability of what? Probability of exactly 2 heads. This is the one I am looking for, right? So you are tossing in total 3 times. Among all 3 times, now I am looking for exactly 2 heads, right? That means what is your success here? When you get heads, then it is considered as your success event, right? Because you are looking for heads. So whatever you are looking for, that's going to be your aim, right? When you get heads, you succeed. If you get tails, then it is a failure. So both of them have equal chance, fixed values, half, right? One half for throughout these all three tossings. Therefore, little p is now fixed and little q as well. So make sure that you are finding all the things. So the question is now, whatever you are looking for, that is going to be your variable x. My x is what? X is number of heads. Okay. Now remember, your x may be now you are tossing 3 times. So you may have heads or you may not have throughout all three, tossings. So you suppose if you get all 3 times, that means none of them are going to be heads. Therefore, x may be 0 or x may be 1. You may have one heads among three, or you may have two heads, or you may have three maximum, right? So therefore, you see now this condition is now satisfied here. Therefore, the possible x values are these. But remember now you are looking for what? You are looking for exactly two heads. Therefore, your x is now fixed to 2, right? Therefore, in this problem, my x is 2. Question is finding the probability when x is 2. That means they are asking you to find the probability when x is 2. So this is my problem. First of all, I am writing px formula. Remember, we already know that this is binomial experiment. Therefore, I will use this px formula. Px formula, I'm using this version, the combination versions rather than writing in explicit form. So I prefer to use this one. So my px is given by n choose x little p to the power x times little q to the power n minus x. Okay, what is little p here? Remember, little p is probability of success for each trial. Remember, you are tossing 3 times. If you consider single trial, that means you are tossing a coin. So you are looking for what? Heads. So what is the probability of getting heads when you toss a coin? Yes, half chance, right? That means you have to find this little p for only one trial, single trial. That means you are tossing only once, you have to consider. When you toss a coin once, what is the chance of getting heads? One half. Failure, getting tails, also one half. Remember, when you add these two, p plus q should be always 1. You see this relationship? Yes, I'm getting 1. You should get always 1. Otherwise, somewhere you made a mistake. Half plus half 1, right? Therefore, p plus q is 1. Good. So then tell me, what is little n? Total number of trials. I'm performing 3 times. Therefore, n is 3. So I know all the numbers. Simply plugging into your formula and find p x is 2. Remember, my x is 2. Therefore, p x is 2 is given by simply use the px formula. I'm using that formula here. And I am replacing x by 2, n is 3, little p is half, and little q also half. So plugging all the values into this formula will give you what? Will give you 3. Choose x is 2 now. Okay, little p is half. Again, x is 2, little q also half, and n is 3 minus my x is 2. Now simplify this guy. Check your calculator. And if you want, you could find first this 3 choose 2. If you type this 3 choose 2, 3 choose 2 is always 3. Take your calculator and check. This is 1 half to the power 2 times 3 minus 2 is 1. So that is 1 half to the power 1. So that means you could type this all in your calculator. 1 half is squared is 1/4, right? 1 half squared is 1 half times 1 half, which is 1/4. Here already I have another 1 half. So 1/4 times 1 half is 1/8. So 1/8 times 3 is 3/8. So you could use the calculator. So the answer is 3/8. That means what? The probability of getting exactly 2 heads among all three is 3/8. So that's the way to use the binomial distribution. Okay, let's move to the next one. The survey found that 1 out of 5 Americans says he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 out of 10, right, will have visited doctors last month. So the survey, the research says that one out of five Americans they used to visit, you know, see the doctor. So remember, if you read the problem carefully, what are we looking for? Find the probability of what? Exactly three, those who are visiting doctors, right? Therefore, you are looking for the number of visitors they see the doctor, right? That means my x is the number of the persons or number of people visited the doctor last month. So I'm looking for this guy, right? Remember, in this particular problem, you should have x is exactly 3, right? That means what is little p? Little p is the probability of single event. So single event means what? Now you are performing 10 trials. You are choosing 10 of people and you are going one by one and asking. So you are going to one first person and asking whether he has visited doctor last month. So he has to say, whether visited or not, right? So you will have always two outcomes, and this is a binomial experiment. Okay. So what is little p? The probability of success. That means the probability of that guy visited doctor. But you know that probability. Research says that one out of five visited doctor. Therefore, little p is one out of five, right? You already know the probability fixed. Okay. So now you are performing a 10 trials. Therefore, n is 10 here. If little p is 1 over 5, 1 out of 5 says yes, they visit the doctor. That means the failure is what? The failure is those who did not see the doctor, right? So that means remaining 4 out of 5 are going to say that they did not, visit the doctor. So that's going to be my failure little q. Understand? So first find these numbers first. Okay, that means what? That means I'm using probability of success x. Formula says that is n choose x, p to the power x times q to the power n minus x. Now I know all the numbers, right? Simply plugging those values. Yes, my x is now 3. So I'm looking for 3, people they have to, visit the doctor among all 10. Therefore, my x is 3, n is 10, and x is 3. Sorry, this will be 3. Okay, so this will be 3. Can choose 3. What is little p? The probability of success for each person, whether they have to visit the doctor. The probability of success is 1/5. So x is again 3, and q is 4 over 5, right? So n is now 10, and minus x is 3. Now simplify this guy. So this is if you want, you could type all in one. So let us simplify. 10 choose 3 times 1 over 5 to the power 3 and 4 over 5 to the power of 7. So type this all at a time, by using calculator if you want. Let me show that. So I'm going to type 10, choose 3. So I need to go to math and choose 3 and times 1 over 5. So let me open the parentheses. 1 divided by 5. Then to the power is this burden, to the power 3. Then again times, open the parentheses, 4 divided by 5 to the power 7, right? That's it, enter. So you got in decimal answer now. So let me write in 3 decimal places, that is 0.201. So that is my probability of, getting 3 among 10. They say yes, they visit a doctor. Okay. Right. Now here we are going to look at how to find a mean, a variance, and the standard deviation for the binomial distribution. Right. Remember my random variable here, x. Right. My random variable is now x. What does mean by x? X is nothing but the number of successes. Right. So that is now going to be your variable. So now we are going to find the mean, variance, and the standard deviation for this x. Okay, there are some formulas you could use those directly to find mean, standard deviation, and variance for the variable x. The mean mu is simply given by the number of total trials times the probability of one trial success little p. So the mean for the variable x is simply n times p. Okay, and the variance for the variable x. So let me recall like this. This means the variable of the variance of the random variable x is given by simply sigma squared. Formula says that that is simply n times p times q, right? When you are given a problem, you will know about n, p, and q. Simply multiply those three, you will get the variance. Once you have variance answer, now we know how to find the standard deviation of x. So that is simply the square root of your variance answer in PQ. So these are the three formulas we use, under binomial distribution. Okay, right. So let's look at this problem. An eight-sided die with a number from 1 to 8 on the faces is rolled 560 times. Find the mean, variance, and the standard deviation of the number of sevens, that will be rolled. You understand the problem? We are rolling a die 560 times. Therefore, the total number of tries is now 560, right? So remember, for each trial, I have now 8 possible outcomes. You may have any number, from 1 to 8. But my, the problem is looking for number 7, right? Therefore, the x is nothing but the number of sevens I'm getting, right, on a die. So this is my x. Okay, so then what is little p here? Little p is the probability of success for a single trial. When you roll a die once, what is the probability of getting number 7? So that is 1 out of 8, right? Because there are 8 possibilities, so my sample space for this problem is 1 to any number, all the way to 8, right? So, but you are looking for number 7. For each trial, you have only 1 out of 8. So this is my little p. Therefore, the little q is the probability of failure for each trial. That is remaining all 7, right? Therefore, 7 out of 8 is going to be the probability of a failure. Okay? Yes, I know all the numbers now. Now, simply plugging into your distribution formula, the probability distribution for this binomial experiment Px is given by n choose x times e to the power x times q to the power n minus x. Now I know all the numbers, right? So we are looking for, uh, we are looking for the standard deviation and the means. Therefore, I'm using a mean formula first. Mean is simply n times p. So we know n is 560 times, and little p is 1 over 8. So simplifying this number. So that is 70. So 70 is going to be mean. Okay. The next variance. Formula says that variance is simply n times p times q. So n is 560, p is 1 over 8 times q is 7 over 8. Simplify this guy. So my 2 decimal place answer is 61.25. Please check whether you are getting this number. Therefore, standard deviation for this problem, that is simply the sigma is given by the square root of 61.25. So this is roughly 7.83. Okay. So finding mean, variance, and standard deviation for a binomial experiment. Okay, so let me explain the first problem from your exercise. Prison inmates. 40% of prison inmates were unemployed when they entered the prison. If 5 inmates are randomly selected, find these probabilities. Now we are going to find several probabilities here. So let me write down the answers somewhere here. So remember, if you want to apply the probability distribution for the binomial, make sure that the given experiment is a binomial. Okay, so you are going to check, five randomly selected people inside the present. So therefore, you are going to perform five trials now. You are going one by one and asking whether they are unemployed, right? So if they say yes, yes, that is the one I am going to look for. So that is my success, and if it is not, it is going to be my failure. But remember, um, the research says that the 40% of the prison inmates they were unemployed, right? Therefore, that is the one I am looking for, the number of unemployment. Therefore, the little p, the number of, the probability of success for each trial is, the 40%, right? The probability is given 40%. So that is 40% means if you divide by 100, you will get zero point 0.4. So this is going to be the success for each trial, and little q is the remaining left over from 100%, right? Which is 60% is going to be the failure trial. Therefore, that is 0.6, right? Okay, so first of all, identify these. Okay, so my number of total trials is 5, because I'm going to ask the 5 people. So these are the numbers. Now let's do one by one. The first one, we need to find out exactly 3 should be unemployed among these 5. So remember, the questions are finding probabilities. Therefore, you need to write down the probability formula for your the number of successes. So therefore, P of x I need. Formula says that for the binomial distribution, that is n choose x times p to the power x times t to the power n minus x. This is n. So remember, for the first part, we are looking for 3 unemployment. Therefore, x is 3. So you know n. Total number of trial is 5. Choose 3. Little p is 40% or zero point 0.4 to the power x is now 3 times my q is now zero point 0.6, and to the power of n is now 5 minus 3. Okay, so that is if I choose 3 times 0.4 to the power 3 times 0.6 to the power 2. Take your calculator, and if you want, you could type all at a time and find the answer. Okay, so if you do correctly, you should get here into decimal places as 0.230. Okay, now number 2, we are going to look at the number of unemployment. That should be at most 4, right? So at most means that the maximum we should have 4. That means now my x should be, or the maximum 4 should, that means any number less than or equals to 4 is the one I'm looking for, right? Okay, so this is the probability now I am going to look at. Suppose if this is your particular event E, so my event E is here, I am going to look at the number of unemployment. So that should be less than or equals to 5, right? So remember, I could change this at most in terms of the complement event. So if you write this as your event E, if your event E is, less than or equals to 4, right? That means my event E bar, complement of this event, the negation of this statement is going to be x is bigger than um, bigger than what, 4, right? Okay, suppose if you have number line here, 0 is here, 1, 2, 3, 4, and so on. So my event is any x is less than or equals to 4. That means your event is any number less than or equals to 4. So this region is now my event E, including 4. That means the outside of this means except this, the remaining all going to be my event E bar. So my event E bar is this side. That means anything bigger than 4 is my event E bar. So that is here. Remember, my possible x values are what? 0, 1, 2, 3, 4, 5. You see, the maximum number is 5 because you are performing 5 trials, right? So you are checking 5 people. So this is my maximum. In another word, this is my n, right? So your x cannot be more than your n value. N is 5. Therefore, these are the possible x values. But remember, for event E, my x values are less than or equals to 4. That means these are all going to be my event E values. Therefore, remaining only one guy is going to be your value for E prime, sorry, E bar. Therefore, if you change this event in terms of the complement, remember we have the formula or the relationship between any event E and its complement E bar. So the P of E is simply 1 minus P of E bar. If my event E is less than or equals to 4, that means the complement event is bigger than that value, right? That is my E bar. So in this particular problem, what are the possible x values, so which are bigger than 4? Of course, I have only one value, which is 5. So therefore, the condition for this event is simply, what is that? That is simply x is 5. Okay. That means what? That means it is enough to find only one value, for this particular event. So now use the probability distribution formula Px again and plugging x for our 5, and you will get, if you use the probability distribution formula again for this Px formula here, use that and plugging all the values. Now x is 5, n is also 5. Therefore, n choose x is 5 choose 5, and the little p is now going to be again the same problem we are doing. So 4.4 to the power 5 now, and q is zero point 0.6, and n is 5. Subtract x also 5. So find this answer. Okay, so when you simplify this is 0.4 to the power 5. So 5 minus 5 is 0. So this is 0. So any number to the power 0 is 1. So therefore these are just 1. So answer is this. Take your calculator and simply find out this value. So if you simplify this is nothing but 0.99. Okay. Therefore, the probability of at most 4 is 0.99. So I'm changing this into the complement event. Okay. Okay. If you want, I could solve this problem in another method. You could do this problem without changing into complement, directly you could do this problem. How? You are asked to find the probability of at most 4. That means your possible x values are what? Any number which is less than or equals to 4. Of course, now I will have 5 possible values for x. Your x may be 0, or maybe 1, maybe 2, maybe 3, and maybe 4. So that means now you need to consider one number at a time and find all the possible probabilities. So I will have 1, 2, 3, 4, 5 different possibilities. Then add them when you will get. That means you have to check the first probability value when x is 0, then add the second probability value plus third plus fourth and the last. So you will have now more work, right? Because you need to use the formula 1, 2, 3, 4, 5 times. So you have to find each number, then you need to add. So you have more work than here. That's why the changing into complement always will be effective method. So if you don't want to do that, and you could do the problem directly, but now you need to use the px formula 5 times. Okay, first time you had to plug in x for 0, second time x is 1, x is 2, x is 3, and x is 4. So if you do that, and you have now a big expression here. So that is px0 is use px formula and simply plugging x0. That means 5 choose 0, n is now 5, q is p is zero point 0.4 to the power 0 times zero point 0.6 to the power of 5 minus 0. And the second one, 5 choose 1, and zero point 0.4 to the power 1, and the zero point 0.6 to the power of 5 minus 1, plus 5 choose 2, and zero point 0.4 to the power 2, and zero point 0.6 to the power of 5 minus 2, plus I need to know 5 choose 3, times zero point 0.4 to the power 3 and zero point 0.6 to the power 5 minus 3. And the last one, if I choose 4 times zero point 0.4 to the power 4 and times zero point 0.6 to the power 5 minus 4. Take your calculator and simplify and finding the value. You see now I'm using that formula 5 times, right? 1, 2, 3, 4 and 5 times because you have now 5 different probabilities. Okay, then find the answer. You should get very close to that answer. Okay, the first one. So this is second method. Part 3, at least 3 were an employment, therefore my x should be now at least means you have to have bigger than or equals to now 3, right? That means my possible x values are now 3, right? 4 or 5. Therefore you need to find now 3 probabilities one by one, find those and find the answer. Okay, so p choose 3, px3 is now, if I choose 3.4 q to the power 3 and the q is 0.6 again and 5 minus 3 plus second probability is now if I choose 4 and zero point 0.4 to the power 4 times 0.6 to the power 5 minus 4 plus the last probability is if I choose 5 times zero point 0.4 to the power 5 and zero point 0.6 to the power 5 minus 5. Take your calculator and simplify. So if you do correctly, you should get 0.317. Okay. Then the last part says find the probability your number of employment should be fewer than 2. That means it should be less than 2 now. The possible x answers now, of course, x should be 0, 1, only 2 values, right? Should be less than 2. Therefore, that is the probability of x is 0 plus the probability of x is 1. Okay. Now find these two separately. So that is, if I choose now x is 0, zero point 0.4 to the power 0 and 0.6 to the power of 5 minus 0 plus the second probability is if I choose 1, 0.4 to the power of 1 and 0.6 to the power of 5 minus 1. So if you simplify, this should be 0.337. Okay. So I have included all the possible things here and make sure that you understand. Okay. So why don't you try the remaining all and I will do more problems in coming meetings. Okay.